Hey, Mr. Richards here. Today's 6th grade, Unit 6, Lesson 13, Anchor Problems. Sarah's purchasing pencils to share. It's nice of her. Each package has 12 pencils. The equation n equals 12p, where n is the total number of pencils and p is the number of packages, can be used to determine the total number of pencils Sarah has purchased. Determine which variable is dependent and which variable is independent. And what depends on what? In this case, the total depends on the packages. And so the independent that's great writing. Independent is going to be the packages. That's a little better. And the dependent is going to be the total number of pencils, as your total number of pencils depends on the number of packages you buy. Make a table for 3 through 7. 3 to 7, including 4, 5, and 6. Then 3, this was n equals, n was equal to 12 times p. And so you want to put 3 in for p. 3 times 12 is 36. 4 times 12 is 48. 5 times 12 is 60. 6 times 12 is 72. And 7 times 12 is 84. And so that's what we're going to graph the best we can here to plot these points on the coordinate plane. Now, I just kind of, since we're working with all positive numbers, I can just draw this line on down, draw this line across. Now, typically your dependent variable is always going to be your x, and your independent variable is going to be your y. There's exceptions to that, of course, but for the most part, your dependent is your x and your independent is your y. Since your dependent was the total number of pencils, no, I'm sorry, I switched that. Erase that, go back, ignore me, don't listen to me, except listen to me now. Let me get this right. Your independent's your x, your dependent's your y. Ugh, that's still your x and your y. Making mistakes, I'm sorry. So your packages are your x. Your total hashtag of pencils is going to be on your y. And so if we just kind of go 1, 2, 3, 4, 5, 6, 7 there. And since we're going up by 36s or going up by 12s, let's just count by 12s going up, okay? Just use your problem to help you set your scale. 12, 24, 36, 48, 60, 72, 84, and then plot the points on the graph. 3, 36, plop was in the office. 4, 48. I hope I mentioned that I'm not breaking copyrights. 5 goes to 60, 6 goes to 72, 7 goes to 84. So there's that. If she has 168 pencils, how many packages did she purchase? Well, that's where you can use the equation and work it backwards, okay? N is equal to 12p. And so basically, your number of pencils was 168. Fine. 168 equals 12 times p. Divide by 12 on both sides so you can get your p alone, because that's typically, never mind. 168 divided by 12. Left with 48 goes in 4 times. That's a 0. So 14 is the number of packages purchased for those 168 pencils. Moving on. The graph below shows the relationship between the number of miles m and the number of hours h spent traveling on Veronica's road trip. Well, she broke quarantine. That's not good. Which variable is the independent variable? Which is the dependent? Well, let me not make this mistake again. The independent is on the x. The dependent's on the y. And so, which variable is the independent? Hours. Which is the dependent? The number of miles. What does 420 or 4200 mean in the context of the situation? Well, 4 is your x, and 200 is your y. It's asking, what does this thing here mean? Well, it means in 4 hours, literally, pull it from the graph, 4 hours. You went 200 miles. Don't overthink it. That's all you need. Describe the relationship between the two quantities. Well, simplify it is basically what that's saying. How far did she go in 1 hour? She went 50 miles in 1 hour. So when you want to write an equation with this, you would say that y always equals something times x, and these things, all right, for now at least, until next year. Y always equals something times x, and in this case, your total distance is equal to 50 times your number of hours. And does that check out? 50 times 1 is 50. 50 times 2 is 100. 50 times 3 is 150. Works for me. At a store closing, everything in the store is 50% off its original price. Write an equation of the discounted price D of any store item with original price P. Well, your discounted price is always equal to 50%. So 0.5 or 0.50 times the original. Could you, if you wanted to be ambitious, write D equals 1/2 P? Yeah, ambition's good. You can write the fraction too. Create a table of values with at least 3 or 4 different original prices. Well, that would be boring if you created the same original prices. Let's do 10, 15, 20, 30, and 40. The discounted price would be 5, 750, 10, 15, and 20 is your discounted price with half of your original. And then graph this, which is conveniently on this piece of paper down here. That's a beautifully drawn line there. Ooh. Making ooh a lot. What depended on what? Your discounted price depended on your original. So this is your y, this is your x. So your original price is going on the x-axis. As we scroll here, and I hope I don't nauseate anyone too much. This is original. This is discounted. And if we just kind of didn't do anything too fancy here, we went up to 40. So if we count by fives, so this would be 5, 10, 15, 20, 25, 30, 35, 40. If we do the same thing going up here just to keep it consistent, 5, 10, 15, 20, not going to have to go much more than that. If you have 10 to 5, 10 is at 5, 15 was at 750, 20 was at 10, 30 would have been at $15, and 40 would have been at $20. So there's a graph. And if I sketch kind of a line, you can see where this is going to be a line. Now, knowing what we had for the next question, how could you use the graph to define the discounted price of something that originally cost 15? Say you didn't draw this point. Say you just did the 10 and the 20. You could look at this graph and go, well, originally when we were at $15, it looks like it's going to be $7.50. And so that's how you could use the graph. So explain how you can use the graph. Draw the line and use to determine the y value when x was equal to 15. And of course, y was equal to half of the 15, which was 750. So I do believe that's it. You scroll through these. That is for these practice problems, or these anchor problems. Good luck.